Hello students, I am Dr. Munir Omar with Database Management Systems. In lecture number 57, the topic is NoSQL. These are the contents for our today's lecture. First, we have big data, then the database scaling, and after that, we will look into NoSQL. Actually, these two will make a base for the need of NoSQL as compared to relational databases. After that, we will study the different types of NoSQL databases, and at the end, we will have a look into the features of NoSQL databases. Big data is a term used to describe a collection of data that is huge in volume and yet growing exponentially with time. Actually, when we say big data, then we mean that the amount is much bigger and complex as compared to traditional databases. So, for big data, we cannot use the traditional database management tools to store and process it efficiently. The massive increase in the data volume within the current decade. If we look into the current decade, due to the excessive use of smartphones with bundle of applications and social media, the volume of data has been increased in multifolds. Social networks, we have search engines, these are using bulky amount of data which cannot be processed by the RDBMS in an efficient way. So handling such amount of data is a big challenge. Now, database scaling. As we know that the volume of data in the databases increase with the passage of time, and also the number of requests for a single database are increased by the users as the volume of data grows in the databases. So the databases must be scaled, we can say their capabilities must be increased. We have two basic scalings. The first one is vertical scaling, also known as scale up, and the second one is horizontal scaling, also known as scale out. So the vertical scaling was adopted when the database couldn't handle large amount of data and also large amount of user requests or user queries. Suppose we have a database server of 1 GB RAM and it has exhausted. It is not capable to handle the requests of users or to process the data with this 1 GB RAM. So now to handle the requests or the processing, what we do, we increase the capability of this server, or simply we can say that we upgrade this server and we install another server having the same database, and this server has now 2 GB, the double RAM, and also 4 CPUs as compared to previous there were 2 CPUs. Now this upgradation is known as vertical scaling. It is buying a single expensive and bigger server. The process involves adding more power such as CPU, disk space, and RAM to the existing system. The relational databases mostly use vertical scaling because it is comparatively easy and a simple way for the upgradation of database servers, and the relational databases can easily adjust in such type of scaling. Then we have horizontal scaling. In horizontal scaling, as the image depicts, is scaling of the server horizontally by adding more machines. It divides the dataset and distributes the data over multiple servers or shards. This is also known as sharding. Each shard as an independent database. Now here we have a single database. What we do, we bring one another system and start using that system parallel with the existing system, and actually we scale this in a horizontal way, or we make two shards, and on both systems, the older and the newer, both will have database, and there would be some mechanism to handle the records on both these systems. Instead of buying a single powerful server, we can buy or we can install multiple smaller or cheap systems in this horizontal scaling. Vertical scaling focuses on increasing the power and memory, whereas the horizontal scaling increases the number of machines. Here, RDBMS are better, and here, NoSQL databases are mostly used. Uh, it is less suitable for RDBMS. The horizontal scaling is less suitable for RDBMS as it relies on strict consistency and atomicity rules. Here we need the asset properties to be implemented or fulfilled properly, but here the consistency and atomicity are relaxed. So the best way to provide asset properties and rich query model is to have the dataset on a single machine, which was suitable for RDBMS in the previous slide, and that was about scaling up. Limits the scaling up or vertical scaling make a single machine more powerful. Dataset is just too big. So this is a big issue, that if we scale vertically, then we will have a bigger machine, and definitely one day that database would also be bigger, and for handling a bigger database we will have more formalities to be followed. Adding more smaller and cheaper server is a better choice, which is scaling out or horizontal scaling. We can easily expand the capability of a database server, and we can divide that database on multiple nodes so that it can store a huge amount of data and also bulky amount of requests from users to be processed on multiple nodes, but the atomicity and consistency are affected in scaling out because we will have some data on a single node and some might be on multiple nodes. So such type of cases, the replicated and non-replicated data may get some issues with atomicity and consistency. So this scaling out is not suitable for RDBMSs. Now, what is NoSQL? NoSQL stands for not only SQL. Some people get confused with NoSQL. They think that it is no and then SQL. In fact, it is not only SQL. So, not and then only and SQL. So, the term NoSQL was introduced by Carl Strozzi in 1998 to name his file based database. This was a simple database, but it was a bit different from RDBMSs. It was again reintroduced by Eric Evan when an event was organized to discuss open source distributed databases. The main point was that to solve the issues or to address the problems which could not be addressed by relational databases in a proper way. So Eric states that, but the whole point of seeking alternatives is that you need to solve a problem that relational databases are a bad fit for. Actually, when the size of database is increased or the requests or the processing of data is high, in that cases the relational database management systems and also the relational databases don't perform well. So the main purpose was to find an alternative against the RDBMSs for such type of problems. If we look into the NoSQL databases, these are non-relational databases. We will not find any tables or columns, the schema for attributes, and we will have no relational model in NoSQL databases. NoSQL databases are flexible databases for real-time and big data. Actually, in RDBMSs, we follow some strict constraints and the system try to fulfill the ACID properties. So for that purpose, the performance may degrade if the amount of data is very high, and also at real time the response may be a bit slower. The document databases store data in documents similar to JSON objects. JSON stands for JavaScript Object Notation. Each document contains pair of fields and values. Values can typically be a variety of types, including things like string, number, boolean, array, and objects, and their structures typically align with object developers as working within code. In key value databases, the items contain keys and values. A value can typically only be retrieved by referencing its key. So, learning how to query for a particular key value pair is typically simple. Key value databases are great for use cases where we need to store large amount of data, but we don't need to perform complex queries to retrieve it. These are useful for large amount data and no complex queries. Then we have graph databases. In graph databases, the data is stored in nodes and edges. Nodes typically store information about people, places, and things, where edges store information about the relationship among these nodes. It is just like simple graph. On node, we will have data, and on edges, we will know the relationship among these nodes. Graph databases excel in use cases where we need to traverse relationships to look for patterns such as social networks, fraud detection, and recommendation engines. Then we have wide column stores. These databases store data in tables, rows, and dynamic columns. Wide columns store provide a lot of flexibility over relational databases because each row is not required to have the same column. Usually in RDBMS, if we are having a row, so that row would be under a particular set of attributes. But here in wide column stores, the NoSQL database, there would be rows, but for each row, the attributes or columns might be different. Many consider wide column stores to be two-dimensional key value databases. Next, we have features of NoSQL. There are many features of NoSQL, but some prominent features are non-relational. Second one is schema-free, and third one is distributed. So the first non-relational, the NoSQL databases never follow the relational model, just like we do in the relational databases. By relational model, we mean that there would be some sort of tables having some columns, and each column will have some features or properties. So, never provide tables with flat fixed column records. We have one type of NoSQL databases, wide column, but this one is also different from typical tables. Here we may have columns, but for each row the set of column would be different. So this one is not a proper relational database. We don't have tables. Work with self-contained aggregates or blobs. We will have binary long objects in these tables instead of these fixed columns or attributes. Don't require object relational mapping and data normalization. Since elimination of redundancy or replication of data would not be in any priority, so in that case there is no need of normalization in NoSQL. No complex features like query languages, query planners, referential integrity, joins, and ACID. As we have all these in the RDBMSs, these are not present in NoSQL, as the NoSQL is non-relational. Then the second feature is schema free. NoSQL databases are either schema free or have relaxed schemas. Now, if we look into the relational databases, then we must have a proper schema for the development and design of databases. There might be some tools which give some facility to reduce the load of designing the schema, like the tool may suggest the type of attribute automatically, but still there exists schema in the relational databases, while in case of NoSQL don't require any sort of definition of schema of the data. Offers heterogeneous structures of data in the same domain. It is like we might have one single entity, and under that entity we may have different type of values. We may provide values having different data types, so it would not create any issue. In the case of relational databases, when we create an attribute, we also define its data type, and we may define the possible set of values or the domain of that attribute. Then the third one is distributed. Multiple NoSQL databases can be executed in a distributed fashion. Actually, the origin of NoSQL came with distributed databases. NoSQL were preferred for their nature of being distributed over the relational databases, though the relational databases are also having support for the distributed data, but still they are not much better than NoSQL. Offers auto scaling and failover capabilities. No ACID properties in NoSQL. Often ACID concepts can be sacrificed for scalability and throughput. In NoSQL, we don't care about ACID, the atomicity, consistency, isolation, and durability. We primarily consider the availability and scalability of data. Shard nothing architecture. This enables less coordination and higher distribution. In the coming lecture, we will study about the gap theorem. This is an important theorem used in NoSQL, and there is another important topic that is about the differences between SQL and NoSQL. Actually, this one is the relational databases. So we can say that the differences between relational databases and NoSQL databases. Hope you will also study these by yourself. This was the first lecture about NoSQL. In the coming lecture, we will resume NoSQL with some other topics. Thank you.